All right, so now that we've gone over the 4 principles of a well-designed experiment and kind of talked about how to use them and why they're important, let's look at an example. And this is actually a very good example, not just for tests, but for your response bias project. We are going to do a response bias project. And for your proposal, you are going to have to talk about how your experiment utilizes all 4 aspects of good experimental design. So basically exactly this question here. So in the caffeine heart rate example, we want to see if caffeine causes a change in heart rate. Explain how you could design an experiment to see if caffeine does in fact cause a change in heart rate. Explain how you would incorporate the 4 pillars of experimental design. So instead of doing this one and doing a ton of writing, I just put down the solutions in italics. So let's just go through it. So first, replication. First, I would make sure that we have enough subjects so that each treatment group has an ample number of subjects. I will get 40 volunteers. 20 people in each group should be enough to balance out all of the uncontrolled variables. Gender, body type, size, metabolism, ethnicity, whatever things I can't control. Excuse me. There will be 2 treatment groups. One group will receive the caffeine and one group will not get the caffeine. That would be called a control group. I will compare the heart rates of these 2 groups after the treatments. This is comparison. I will divide subjects into 2 treatment groups. I will write each subject's name on a slip of equally sized paper. I will put the slips of paper into a hat, mix the hat thoroughly, and I will draw out the slips one at a time without replacement. The first 20 names will be placed into the caffeine group. The remaining 20 will be placed into the control group. This is random assignment. Control. I did this as bullet points because there's a lot of different variables we can and should control for. So the first one, I will make sure each subject has no breakfast, no soda, and no coffee the morning of the experiment. We don't want anything to kind of increase the variability in heart rate. I will make sure all subjects have had ample time to sit and rest before the experiment to the heart rates, so their heart rates settle to a resting rate. So when they come to the class, they might be tired having ran up the stairs or ran from their car. I'll make sure everyone has rested and their heart rate gets to a nice resting count. I will make sure each person in the caffeine group takes the exact same dose of caffeine. I will use a caffeine pill. So I'm not going to let some people take a little bit and some people take a lot. They'll all take exactly the same amount. I will make the control group take an identical looking pill that has no sugar and no caffeine. We don't want any usually a placebo is a sugar pill, but we wouldn't want it to be a sugar pill in this case because maybe sugar would cause an increase in heart rate. So the no caffeine group is not going to get any sugar nor any other substance that may affect heart rate. I don't know what kind of pill we're going to give them. Some kind of, chalk pill or something. I don't know. Both groups will take a pill, so both groups have the same amount of the placebo effect. I don't like how that's worded. So both groups will have the same what's the word? Psychological effect? It's fine with the placebo effect. They'll all have the same psychological effect of I'm taking caffeine, I'm taking a pill, and it may increase my heart rate, so I think it will increase my heart rate, so maybe it does increase. So they'll all have that same psychological effect. Subjects do not know which treatment group they are in, so the experiment is blind. I have a group of people trained in measuring pulse rates. Do I have a typo here? And I have a group of people trained in measuring pulse rates, and they will measure all the subjects after a set amount of time after the pill was consumed. I think there's a typo here, I'm sorry. But basically I'm going to wait a set amount of time for the caffeine to take its effect, and then I'm going to have a group of trained people measure the subject's heart rates. This will reduce possible errors in heart rate measurement by students or untrained subjects. If we follow this procedure, we have a good chance or a better chance that if caffeine really does increase your heart rate, that we'll be able to detect it and prove that it does cause a change in heart rate. But maybe it'll work, maybe it won't. This is what I want on the proposal whenever we do our experimental proposal. And this is the type of thing you should think about anytime you design an experiment. Okay? All right. So blocking. We studied what was basically a completely randomized design experiment. That's what we just talked about. You take all the subjects and you randomly assign them into the treatment groups. But there is another way to control variables. So we said there were uncontrollable variables like gender, GPA, or teacher. We said there were some variables we can't control. Blocking allows us to control one or more, maybe, of these previously uncontrollable variables. I don't know how to spell uncontrollable. I'm sorry. So if we have a variable that really might have a drastic effect on the response, like the heart rate measurement or whatever we're measuring, then we could actually block for that variable. So here's how blocking works. Let's start with an example, SAT scores. Many students enroll in prep courses to improve their SAT scores. 20 students who have taken the SAT once volunteered to participate in an experiment comparing online to classroom prep courses. So you guys are maybe aware of these prep courses that help you improve your SAT scores. So one type might be an online course, and the other one might be an in-class class. Describe how we can use a completely randomized design. So completely randomized design always takes your subjects and breaks them into two groups. So we have 20 kids. So we start with our 20 kids. We do random assignment. Random assignment, we're going to break them into probably 10 kids and 10 kids randomly. We're going to assign these to the online class. They will take the online class. We'll give them the treatment. And then the in-class class, we will look at their SAT change, their change in SAT scores, and then we will compare. So this is a completely randomized design. Here are the results of the experiment. Make dot plots to compare the improvements of the students in the online and the improvements of the students in the classroom course. Based on these dot plots, does there appear to be convincing evidence that the online course is better? Okay, so let's do a little comparison here. I'm going to do an over and under dot plots. So this is going to be online. I got to leave a little more space. Online, and this will be class. So it looks like the scores, these are improvement scores. So the improvement scores range from 0 to 100. That should be easy enough. Let's go 20, 40, 60, 80, 100. Do the same scale down here. Excuse me. Okay. So these are improve, SAT improvement, SAT improvement. We'll just call it that. Okay, so online we had a 100 increase, a 100 increase, two 90s, and another 100. Let's just do all the online. 50, 60, so 50, 60, 40, and two more 30, 30. So those are the improvement scores for the online class. Now look at the in-classroom class. So let's go 70, 70, 80, 80, 80, 30, 40. 30, 40, 20. Sorry, it's the 20. And then 0, 20. Okay, so let's compare. Now, what's working against us, and you guys, I don't know if you can articulate it or not, but what's working against us is the spread. The fact that both of these are pretty spread out makes it really hard to compare and to see if there's actually an improvement. It does seem like there's a general improvement. Like, it looks like there's a general shifting here. It looks like these are centered here and these are centered there. But the thing is there's so much variability that this type of difference in average could come just from the random assignment. When I randomly assigned these 20 kids, these 20 ended up here and these 20 ended up there. If I did another random assignment, if this one kid just ended up here and this kid ended up down there, things are going to look completely different. And maybe if one or two of these ended down here and one or two of these ended up there. So maybe the reason we're seeing these differences is just due to the random assignment to the groups. I would say I really don't think there's a significant difference in these two groups. There's too much overlap. There's too much variability. So I would probably say maybe not enough evidence. That online is better than the classroom. There's some evidence, right? Looks like they're a little better, but I don't know about significantly better, okay? Again, what's working against us is all this variability. Oh, and by the way, later on in the year, we're going to learn how to see if we're going to learn a formal test to see if there's a significant difference in these two groups, okay? But we're quite a ways away from that. Blocking. So what is this about blocking? Because each student is a different level of math student, each student has learned different amounts of math. This adds variability to the study. To control for math, we can use blocking in our experimental design. We can't control for math in the original completely randomized design because I can't control how much math a kid has had. But we could block that variable and do a randomized block design. So let's see how this could possibly work. So this isn't the context of the online study, but what it is, we take our volunteers and then we block by a variable that we think is going to have an effect on the responses. So we maybe put smartphone users in one group and non-smartphone users in the other group. And then you randomly assign these 4 to the different keyboards, it looks like, and these 6 to the different keyboards, 3 and 3. And then we compare these people to each other and these people to each other, and then we can kind of look at the overall results. But we basically compare within the blocks. It's almost like we're doing 2 different experiments, if you will. So we can kind of see if the keyboards are different for smartphone users, independently of seeing how keyboard differences may affect non-smartphone users. Okay?